Hello everyone, this is Team 9 and our project is about the activity recognition and classification in videos. This is the outline of this presentation. First, I will introduce some basic information about our project, and then I will introduce the approaches we use in this project, and after that, I will state the results from our experiments, and then I will introduce some errors analysis, and the last part is a literature review. First, why we need activity classification in videos. As we know, more and more security cameras are used in everywhere. Like this from the doorbell, and this from the flood camera, and from this many security cameras we will have a huge amount of data, and if some security issues happen, people need to check the videos by themselves. So if the computer can do this instead of us, and we will save a lot of time. And in our experiment, we use KNN, which is K nearest neighbors algorithm, to implement our classification. KNN is a non-parametric supervised learning method, and it is always used for classification and regression. This is an example of KNN. So the test samples to be classified either to blue squares or to red triangles, because it depends on the value of k. And if the k equals to 3, and it is assigned to the right triangles, and if k equals to 5, it is assigned to blue squares. And here is the MEI and MHI. MEI is the motion energy image, and MHI is the motion history images. So the left part, you can see it describes a person from standing up to sitting in a chair, and here the left part is motion energy image, and the right part is motion history image. So you can see motion history image encodes the process of an object or subject time by time. It's continuous. And this is the dataset we use for our project. We have 25 participants in this video dataset, and each participant acts 6 actions, which are walking, jogging, running, boxing, hand waving, and hand clapping. And for each action, it is conducted in 4 scenarios. First one is homogeneous background, and the second is the first one plus scale variations, and the third one is the second plus different clothes, and the last scenario is lighting variations. The first process is to calculate the MEI and MHI. For each type of scenario, we use a specific state to calculate the MEI, and then we use a size of 2 opening operator to eliminate the false positive motion pixels in MEI to gain more accurate results. And for the calculation of the MEIs and MHIs, a specific tau for each action was used, and the tau was decided by the smallest average Euclidean distance. And in order to obtain the representative features of the MEI and MHI, we implement a function of Hu moments. And after that, we will need action classification. As I described before, we use KNN algorithm with uniform weights. And for the training data, the actions from person 11 to person 18 compose the training data set, and in each scenario we choose 4 frames. And for parameter tuning, we select one frame from each scenario from the actions of person 19 to person 24. And after that, we use 2 testing datasets. The first one contains the actions in scenario 1 from person 2, 3, and 23. And while the testing dataset 2 use the actions of person 2, 5, and 23 in scenario 2. So here is the arrow race with the number of k nearest neighbors. From the figures, we can see it clearly that when k equals to 5 kn performed best. And the local optimal is obtained by tuning the parameter of state and tau. As I described before, the parameter training is implemented by using the validation dataset, and here is the tau value for the 6 different actions, and the value of state was set to 15, 10, 10, 20, corresponding to the 4 scenarios. And here is about the results. The features 2 shows some examples of the MHS for the 6 actions. And the confusion matrices for these 3 datasets, the overall accuracy for the validation dataset is 0.65, while the accuracy for the dataset 1 is 0.8, and for the testing dataset 2 is 0.68. Figure 3 shows some examples of correct classification, and Figure 4 shows the examples of incorrect classification. So for the first image, it should be the walking action, and the KNN source is hand waving. Here comes our results. Among the 6 actions, boxing has the best accuracy, and it's difficult to discriminate running and jogging action, especially for actions in scenario 2. In boxing, hand clapping and hand waving usually cannot be distinguished from each other perfectly. I think it may be because the algorithm rely on the arm movements much more. And we made some error analysis, and the first one is about the threshold state. To categorize the motion part for the image is crucial. If state is too large, the key feature of the motion may be overlooked. And if the state is too small, the noise may remain in the image and mess up with the classification. The second possible reason may be because the speed of the actions may differ. Though the model searched the overall range of tau, the optimal tau still has chance to fall out of the range. And the third reason is in some frames, the person may conduct a secondary action in addition to the primary one. As shown in Figure 7, The action of boxing was misclassified as jogging because the person's legs were also in motion. And the last reason is because the who movements do not always extract the image representative features in a translation, rotation, and scale invariant manner. So using who movements to extract the image features has its inherent limitations. We also made a literature review. Here is a link about the similar project. In this project, the author used an instant threshold state equals 14 for all kinds of activities, and the tau value is also different from our mode. I think the reason may be because the dataset we use are different, such as our project has, for each action we have different scenarios. The author for this project also compares some other methods in his article, but we don't have enough time for the compare. Thank you.